Welcome back to the Tantray Sir Physics classes. Today's lecture is on, again, how to locate the center of mass. But now I want to locate the center of mass of extended bodies, where density may be non-uniform. And where density is non-uniform, you must know, in order to locate the center of mass of those asymmetrical bodies where density is not uniform, we need to use calculus. So, first of all, I had to develop a formula. How to find the center of mass of those bodies where density changes, or extended bodies, or asymmetrical bodies. We need to do a little calculus. Calculus भी क्या? उसमें differentiation और integration के basic rules आते हैं. So first I need to develop a formula for that. Number one. You see, if I want to find the center of mass of discrete bodies, M1, M2, M3, I must know M1, M2, M3, M4, उनके coordinates कहाँ है वो located in the coordinate system. तब जाकर बहुत easy हो जाता है, जो मैंने last time आपको बताया. The axiom is M1 x1 plus M2 x2 plus M3 x3 whole divided by mass of all the bodies together. But if we have a extended body, a single body, which is a mass distribution, and maybe where density is not uniform, so in that case, what is the formula? Or it may be a single body, but the body may not be uniform like this, a rod like this. It may not be a rod like this. It may be an object like this. Here the moment of, center of mass lies at the center, but here the center of mass may not lie at the center. It may be shifted toward the greater mass side. So how to locate the center of mass of such bodies? So here we need to use calculus. Okay, now first of all, how to design a formula for that? How to develop a formula? Now see, center of mass of discrete bodies axiom is equal to M1 x1 plus M2 x2 plus M3 x3 divided by M1 plus M2 plus M3 plus so on plus so on. This is the formula for discrete objects. M1, M2, M3 located at different positions. Their individual positions are given by x1, x2, x3. This we have already done. But now, if there's a single rod, but whose density is not uniform, or there's a rod which is non-uniform, I mean, which is not a symmetrical rod whose center of mass is at the center, is a asymmetrical rod. So in that case, what we do, have a look how to convert this formula into a formula where in calculus-based formula, or where we need to use integration. Axiom again is equal to, what is this? It can be written as summation mx. It can be written as summation x, summation m. It is the same thing as m1, x1, m2, x2, m3, but it is a symbolic form of summation. This can be written as like this, and this can be written as like this. Axiom, if it is now a extended body, not discrete bodies, but continuous body. So this summation is converted into integration. This one, after all, what is integration? It's a summation over continuous distribution. This m and x is written as like this, but m is written as dm, mass of a small element of the mass distribution. जिसका हमें center of mass निकालना है, उस body का छोटा सा element लिया. Whole divided by summation of integration of m dm. This is the formula. That's all. I arrived at this formula through two steps, only to remember it, where from it comes. It comes from, it is summation of this, but summation over continuous distribution is integration, and in the denominator we have summation m, but it is integration of dm. If d and integration cancels, it becomes the total mass of the whole system. So this is the formula that we are going to use. Okay, now let me use this formula. Let me use this formula to find the center of mass of some bodies. How to use this formula? How to use this formula? Formula is this: axiom, center of mass position, of extended bodies, integration x dm whole divided by integration of dm. This is the formula. But integration limits, what is the lower limit, what is the lower limit, and what is the upper limit, depends upon the actual problem, actual situation, what we are dealing with. Okay. Second, this is a rod, this is an x coordinate, a y coordinate, and on this is a rod of length L. If I ask you why is the center of mass, your answer is at the center. That is what we know. But this rod, its density is not uniform. Its density is, let me suppose lambda, that is called kx. That means density is the function of x, means density varies with x. That means if you go to the right side of the rod, the density increases, and obviously the mass also increases, where lambda is linear mass density. Linear mass density. Linear mass density. How to find the center of mass of such a mass distribution? How to find it? कैसे find किया जा सकता है? Lambda is not the same. It is changing with x. If you go to the right side, the mass will increase because the lambda also increases. Lambda is linear mass density, and it is dm by dx. That is mass per unit length. Small mass element by small length element is the linear mass density. Okay, what we do is, I take a small element here, dx. How much away from the origin? X. What is it, the center of mass? Is mass point ka at its own center, because the mass element is very small, therefore its own center of mass is here. I had to find the center of mass of the whole rod. For that, I had to use that formula. So xcm is equal to integration xdm whole divided by integration of dm. So what are the integration limits from here? It is 0 to L for whole rod and 0 to L for the whole rod. So what should I write now? xcm. There is integration 0 to L x. What is dm? Dm of this element. Dm of this element is mass of this element is lambda dx. Lambda into dx, obviously. Dm is lambda into dx whole divided by integration 0 to L. What is dm? That is lambda dx. Okay, but now you can't do that. Lambda and lambda cancels, or you cannot get this lambda out of integration or this lambda out of integration, because lambda is not constant. As usually we have lambda as constant, but here lambda is a function of x. Therefore, we have to substitute for lambda before we get anything out of this integration. So what we do is, xcm is equal to, it is 0 to L x. What is lambda? That's kx dx divided by 0 to L, what is lambda? Again kx dx. Now you can get this k out because k is a constant. Here k is a constant. Lambda is not, but k is a constant. Lambda can be brought out of integration. उसको यहाँ भी बाहर निकाल सकते हैं और यहाँ भी बाहर निकाल सकते हैं, और लास्ट में यहाँ और यहाँ कट हो जाएगा. So what is xcm? Integration 0 to L, k बाहर निकालो, it is x square dx, और नीचे जा करके k बाहर, इंटीग्रेशन किसका? 0 to L x dx. ऐसे कुछ. This k will get cancelled, but don't forget that what I have to do, I have to find center of mass of this rod. वैसे सेंटर पर तो होगा नहीं, it will be shifted away from the center on the right side because right side का मास ज्यादा होगा. Okay, now xcm is equal to, ऊपर इंटीग्रेशन हो गया x cube by 3 0 to L, और नीचे इंटीग्रेशन होगा x square by 2 0 to L. तो अब जाकर के इस चीज को रब करेंगे. चलिए, अब ये चीज जो है xcm, दैट इज ये 2 ऊपर जाकर के 3 नीचे, ऊपर जो एक्स क्यूब है दैट इज एल क्यूब माइनस 0 क्यूब, जब सबस्टिट्यूट किया जाए एल इसको एल एक्स को एल वैल्यू दिया जाए, नीचे व्हाट एल स्क्वायर माइनस 0 स्क्वायर। ये मैंने क्या किया, ये 2 को ऊपर और 3 को नीचे और x को ये l वैल्यू दे करके माइनस 0 क्यूब, इट इज l स्क्वायर माइनस 0 स्क्वायर। दीज आर द बेसिक रूल्स ऑफ इंटीग्रेशन। पहले ऊपर वाला लिमिट सबस्टिट्यूट करना पड़ेगा, फिर नीचे वाला लिमिट सबस्टिट्यूट करना पड़ेगा, बीच में माइनस रखना पड़ेगा। सो xcm इज इक्वल टू 2/3 l cube by l. This is the answer. So it is not at the center, it is shifted away from the center onto the right side. Okay, this is how we use the formula to calculate the center of mass of that rod whose mass is non-uniform or whose density varies with position or distance. Okay, third point. चलो जी, और एक क्वेश्चन हम करेंगे इसी फॉर्म में ताकि थोड़ा सा और प्रैक्टिस हो जाए। ये फिर से कोऑर्डिनेट सिस्टम हमने बनाया, ये फिर से रॉड टाइप, लेकिन अब के बाद जो इसका जो डेंसिटी है, लीनियर डेंसिटी दैट इज ओके 2 + x, ये है इसका लीनियर मास डेंसिटी, दैट इज लीनियर मास डेंसिटी। लीनियर मास डेंसिटी का मतलब है मास पर यूनिट लेंथ, dm/dx. We can't write m by x, total mass by total length, because that is only possible if it would have been uniform. In case of non-uniform linear mass density, the formula is dm/dx. Small mass by small length. Okay. Now we want to find this center of mass of this rod. So get an element here. That element is x here. This is dx. Okay. Now, how to locate the center of mass of this rod? What is the formula? Xcm is equal to integration. Okay, again 0 to L integration. X dm divided by integration 0 to L dm. This is the rule. ये हमारे पास फॉर्मूला है। तो अब जाकर के Xcm is equal to 0 to L x. What is dm? That is lambda dx whole divided by, okay, it is 0 to L. What is dm? Again lambda into dx. But again here you cannot get this lambda out here and lambda out here and cancel it, cut it here. वो आप नहीं कर सकते क्योंकि लैम्डा जो है ये कांस्टेंट खुद नहीं है। लैम्डा मास linear mass density varies with position because x is here. So what we do is we'll substitute for lambda. So that implies xcm is equal to 0 to L x. What is this lambda? That is 2 plus x dx divided by 0 to L 2 plus x dx. xcm is equal to, ऊपर जो है हमने करना है 0 to L 2x dx प्लस, हाँ x को मल्टीप्लाई कीजिए इसके x के साथ, इंटीग्रेशन 0 to L x स्क्वायर dx। मैंने ये किया, इसको मल्टीप्लाई दोनों को किया और इंटीग्रेशन, ये इंटीग्रेशन करना पड़ेगा, 2 को x मल्टीप्लाई और x को मल्टीप्लाई, और इट इज इंटीग्रेशन ऑफ द सम इज सम ऑफ द इंटीग्रेशंस होल डिवाइडेड बाय इंटीग्रेशन 0 to L 2 dx प्लस इंटीग्रेशन 0 to L x dx। ये भी इंटीग्रेशन ऑफ द सम इज सम ऑफ द इंटीग्रेशंस। तो xcm किसके बराबर, ये 2 बाहर और x का इंटीग्रेशन x स्क्वायर बाई 2 अंडर द लिमिट 0 to L प्लस x स्क्वायर का इंटीग्रेशन x क्यूब बाई 3 0 to L होल डिवाइडेड बाय 2 बाहर dx का इंटीग्रेशन ओनली d और इंटीग्रल विल कैंसिल x अंडर द लिमिट्स 0 to L प्लस x का इंटीग्रेशन x स्क्वायर बाई 2 अंडर लिमिट्स 0 to L। ये खत्म होगा। अब यहां पर हमें वैल्यू देना पड़ेगा x को पहले L फिर x को 0 और थोड़ा सा सोल्यूशन इसका करना पड़ेगा। चलो यहां पर और एक स्टेप में करना चाहूंगा। xcm इज इक्वल इट इज x स्क्वायर दैट इज L स्क्वायर माइनस 0 स्क्वायर प्लस 1 by 3 it is L cube minus 0 cube divided by 2 it is L minus 0 plus 2 ऐसे ही x को L minus 0 plus 1 by 2 L square minus 0 square। ये चलो लेट्स गो अहेड। चलिए यहां मैं लाना चाहता हूं इसको। xcm इज इक्वल टू इट इज L स्क्वायर प्लस 1 by 3 L क्यूब डिवाइडेड बाय 2 times L प्लस L स्क्वायर बाय 2। ओके ऊपर L स्क्वायर कॉमन दैट इज 1 प्लस L बाय 3 डिवाइडेड बाय it is L common that is 2 plus L by 2। okay now xcm is equal to 1 8 gets cancelled, this is L 1 plus L by 3 2 plus L by 2। now L we already know it is 6 meters, so it is 6 into 1 plus 6 by 3 divided by 2 plus 6 by 2, that is xcm is equal to that is 6 into 1 plus 2 divided by 2 plus 3, that is 6 into 3 divided by 5, that is 18 by 5, that is 3.3.3.3 3.6 meters. That's the answer. So again here the center of mass will be shifted from the center onto the right side. 3.6 will be the answer. Okay, now let me go to the fourth point. The fourth point is, okay, this was all about how to use the integration and differentiation or calculus for finding the center of mass of non-uniform bodies, where this is what you call as the density varies. Density is not uniform. Density uniform hota to center mein hi aa jata। Okay, now let me go to one more। Okay, fourth, last time I told you how to find the center of mass of a disk which has a missing mass, And I want to give you one more example on that. Suppose there's a sphere. It's a sphere, solid sphere of radius r. It's a solid sphere, and it is this part is there's a cavity here. There's a cavity. We have to find the center of mass of this sphere with this cavity. So what to do? It's we have to find center of mass of this part. Again, we will use the same technique. I will add this part, r by 2 sphere part, solid part. I have added this solid part, and it has become now full sphere, full solid sphere. Center here. So if I add this over here, the center of mass will shift to the center of the solid sphere. The center of mass will be here of the solid sphere if I put it here. So what is the volume of this part? This volume is, okay, V1, that's equal to 4 by 3 pi r cube minus 4 by 3 pi r by 2 whole cube. That is V1 equal to 4 by 3 pi r cube 1 minus 1 by 8 here. So that will be 4 by 3 pi r cube 7 by 8. This is the volume of this part. What is the volume of this cavity part? That is V2. That is 4 by 3 pi r cube by 8. If I put 4 by 3 pi r by 2 ka cube, that is 4 by 3 pi r cube by 8. Okay, what is its x coordinate? What is its x coordinate? This which I have to find. Let me suppose this is its x coordinate, which I have to find. So its x coordinate is x1. What is its coordinate? It is not here, it is here. So its coordinate is this. It is put here to make it a full one. Its coordinate is x2, that is r by 2. Now, when I put it here, it will become a full sphere, solid one. Where lies the center of mass of the total sphere? That is at the center here. That is coordinate origin of the coordinate system. That is 0. That is 0. Center of mass of the full solid sphere. What I have to find? I have to find this x1. So let me use the rule. V1 x1, volume of this partial sphere into its center of mass, plus volume of this V2 into its center of mass, that is x2, divided by V1 plus V2 is equal to, that is this plus this, both together, the center of mass of these two bodies together combined is equal to 0 here. So what is V1? That is 4 by 3 pi r cube 7 by 8 x1 plus, what is V2? That is 4 by 3 pi r cube V2 there by 8 x2. What is x2? That is r2 by 2, r by 2 is equal to 0. Is equal to 0. This is equal to 0 because V1 plus V2 multiplied to this is 0. So this will cancel. It is 7 by 8 x1 plus this will cancel. 8 is here. R by 2 is equal to 0, but 8 is here. 8 gets cancelled. So what is 7x1? That is minus r by 2. What is x1? That is minus r by 14. Here the center of mass of the solid part only is r by 14 on the negative side. That's all. Fifth point. Fifth point. Fifth point. Fifth, let me give you one more simple example. There's a rod of length L. I will put this rod in a form of V shape. I'll put this rod L in the form of V shape like this. V shape. And the angle is, okay, 60, let me suppose. And I have to find the center of mass of this V shape, where the center of mass lies from this A point. That's all. What is the center of mass of this V-shaped figure away from this point? What is the center of mass of this rod, which is half of it? Of course, V shape जो बना है वो इसी rod का बना है V shape. इसलिए ये भी L/2 है, ये भी L/2 है. अगर ये L/2 है, ये वाला पार्ट L/2 है, तो सेंटर ऑफ मास कहां पर है? यहां से कितना दूर है? L/4. तो यहां पर सेंटर ऑफ मास कितना दूर है? यहां पर, यहां से, वो भी L/4. सो अगर ये टोटल डिस्टेंस L/2 है, तो सेंटर ऑफ मास सेंटर पर लाई करेगा. वो सेंटर ऑफ मास जो है वो कितना दूर है ए से? दैट इज L/4. दिस इज L/4, दिस आल्सो L/4. टोटल फ्रॉम हियर टू हियर इज L/2. क्योंकि ये जो V शेप है ये L से बना है. तो अगर L से बना है, फ्रॉम हियर टू हियर इज L/2, फ्रॉम हियर टू हियर इट इज अगेन L/2. सो दैट टोटल लेंथ इज L. Okay. Now, why is the center of mass of this point and this point? This rod is the center of mass here. This rod is the center of mass here. Therefore, both the rods together have a center of mass at the midpoint here. So, if you draw a perpendicular, that perpendicular pass through midpoint. So, the center of mass of this V-shaped figure is here at this point. Here. Center of mass of this part of the rod is here. Center of this part of the rod is here. And the center of mass of both the rods, system of two rods, is here, because it will lie at the center of this point and this point, because this point and this point mass is uniform. ऐसा नहीं कि इसका मास ज्यादा है तो it will be shifted upwards, या इसका पार्ट का मास ज्यादा है तो it will shift downwards. ये तो सेंटर पर ही लाई करेगा, लेकिन ये 30 डिग्री का एंगल बनेगा. तो मुझे बताइए AO, how much distance is AO? ये जो सेंटर ऑफ मास है कितना दूर है A से? That's all. So it is very simple. इस ट्रायंगल में से मुझे आप बताइए cos 30 किसके बराबर है? Base AO by hypotenuse, that's from here to here, that is L/4. So that is √3/2. It is AO into 4/L. 4/L. What is AO? AO, that is √3L whole divided by 8. Yes, this is the answer. And rest of the questions can be downloaded from the app Tantray sir physics classes. Can be downloaded from Google Store. Okay, this is this third lecture on this, and tomorrow it will continue for a few more lectures, and finally we will start the rotational dynamics में ये it will be something like angular moment. Then we will start angular moment. Thank you.